Find the binomial expansion of 1 plus 4x to the power half, up to and including the term in x squared. Find the binomial expansion of 4 minus x to the power minus a half, up to and including the term in x squared. State the range of values of x for which the expansion in part B1 is valid. Find the binomial expansion of this, up to and including the term in x squared. So let's have a look at this then. I've got the question summarized here. So part A then. So here, let's have a look at it then. Here, this 1 plus 4x to the half is equal to, and let's read it out then, 1 plus nx, so it's a half, times x, plus n minus 1, times the x squared over 2 factorial, plus dot dot dot. So there it is there then. That's equal to 1. 4 over 2 is 2, so 1 plus 2x. Minus, there's one minus here, so that's a minus. There's 2, 4, 8 underneath, and there's a 4 squared, 16 on top. 16 over 8 is 2. Lots of x squared. So there's part A. Now that would be valid, provided that the modulus of 4x, the x is less than 1. And just to note, that would tell us that x is less than a quarter, wouldn't it? Take the 4 out and move the 4 underneath, the inequality. So just something by way of reference there. So B, find the binomial expansion of this then, 4 minus x to the minus a half. Here, 4 minus x to the power minus a half. I'm going to take the 4 out, and it's 1 minus x over 4. And that's all to the power minus a half. Using properties of indices, that's 4 to the minus a half, which is 1 over 4 to the half, which is 1 over 2, times the 1 minus x over 4 to the minus a half. So we can use the binomial theorem now, easily. A half, 1 plus n times x plus n minus 1 times x squared over 2 factorial plus dot dot dot. So what have we got here then? Close brace. So that's equal to a half here. Minus times minus is a plus. We've got 8 underneath here. Times a half is a 16th. So it's x over 16. Here, here we've got 3 on top with 3 minuses. 1, 2, 3, 4 minuses, so it's a plus again. It's an x squared. There's a 3 on top. Okay, 2, 4, 8, 8, and this is 4 squared. So I'll do it the other way around. 16, 32, 64, 128. Plus dot dot dot. But there's a half outside, isn't there? So that's 256 now. So let's just put that in. Easy to forget. 256. So it's a half of this, 4, 8, 16, and a half of this, 16, 32, 64, 128, 256. There we go. So that's part 1. Now the range of validity, where x is valid, well here we can see that minus x over 4 modulus of needs to be less than 1. So that tells us that the modulus of x, take the 4 out, drop the minus, the 4 comes underneath. So we can move it to the top the other side. So modulus of x is less than 4, i.e. minus 4. X lies between minus 4 and 4. So there's the range of validity then. for part 1. Find the binomial expansion of this. Okay, so we've got that. So part C. Part C then. Okay, so we've got the square root of, which is power half, which I'll write it as power half. We've got, what have we got? It's 1 plus 4x over 4 minus x, all to the power half. 1 plus 4x over 4 minus x to the power half, which is equal to the 1 plus 4x to the half times the 4 minus x to the minus a half. We want to expand this. Now we can use these two series we've got then. 1 plus 4x, 1 plus 2x minus 2x squared plus 2x. Let me just remember what it was. I'll flick back up. Here it is here, 2x minus 2x squared. That's the first one. Times the 4 minus x to the power minus a half, which is what we had here. So that's these three terms. Half plus x over 16 plus 3x squared over 256. So let's see what we've got then. So that's equal to, okay, so we've got one of these, and one of these, so it's a half plus x over 16 plus 3x squared over 256 plus 2x times a half is 1x. 2x times this is x squared over 8, isn't it? That's that done. And then minus 2 times a half is minus 1 lot of x squared. So what have we got then? We've got a half, and that's all, constants wise. And then we've got an x over 16 plus an x is 17x over 16, isn't it? Okay, and we can tap that on the calculator if we need to. We've got 3 over 256 plus an eighth minus 1. So let's 3. So let's just do the calculator then. So it's 3 over 256. 3 divided by 256 plus an eighth plus 1 divided by 8 minus 1 equals minus 221 over 256. Lots of x squared plus dot 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 plus dot dot dot. So there's the first three terms up to x squared, the binomial expansion of. And I think that was the last piece of the jigsaw there. Yeah, which we've done.